All right, so finish with the quiz. Let me open up notes. Where am I at? Where am I at? So on these particular type of reactions, we use something called the activity series on these. So if you see that with the arrow in your notes, that's what's called your activity series. Like I said, these will not be on the quiz on Friday. We'll have these, and the type we learn tomorrow, a quiz on Monday. So single replacement reaction occurs when one element displaces another element in a compound. You must check the activity series to make sure that the lone element is active or strong enough to displace the element in the compound. So when we talk about being strong enough, it has to be higher on the activity series. So before you go to the trouble of writing it and all that good stuff and balancing it, you always want to check your activity series, because if the element that is by itself is not stronger than the element it's trying to displace, then the reaction will not occur, and you'll just put NR for no reaction. And you won't have to balance or write it out or anything like that. So if we're looking at these, I have a compound plus a single element, and that single element is trying to displace something in the compound. If it's strong enough, if it is higher up on the activity series, it will be able to do that, and then you'll have a new single element. Metals replace metals, and non-metals replace non-metals. So you got to remember that too. All right, let's look at our activity series before we come back and we do these reactions. So if you look at the activity series, this is going to be your strongest. This is going to be your weakest. All this stuff, you don't have to memorize all of that little stuff. That I don't really see an importance in that. But anyway, so this is, and you don't have to memorize the activity series. You'll be given one. But it has to do with which elements are more reactive. There's a side for metals and there's a side for non-metals, with the exception of hydrogen. Even though it's a non-metal, it replaces or tries to be replaced by a metal. So that's why it's listed with all the other metals. Non-metals only replace non-metals. Metals only replace metals, with that exception of hydrogen. So in other words, I should never be saying, oh, can potassium replace fluorine? If I'm doing that, then I'm comparing a metal to a non-metal, and then that's not correct. So the element that is all by itself has to be higher on the activity series than what it's trying to replace. If it's not, then we end up getting what we call a NR, a non-reaction. You do have a lot of diatomics on these, especially if you're trying to replace a non-metal with a non-metal. So don't forget about your diatomics. And if you notice now, you have them pretty much all listed here. If you need help remembering them sometimes, so those will be in your notes. All right, so if we just look here, lithium is an element all by itself, and it has potassium chloride that it's trying to react with. Lithium is a metal, so that means it's trying to replace the metal in this compound, which would be potassium. So then I have to look, is lithium higher on the activity series than potassium? Yes. So that's going to be a good reaction. And I'm going to get a new compound, lithium chloride. And now my potassium will be all by itself. If it's a good reaction, you're often forming at least one new ionic compound, which is right here. Remember, you've got to check your charges and make sure it's written correctly. In this case, lithium is a +1, chloride is a -1, so I did not need to give it any subscripts. Next one, if I look at tin, tin is a metal, so it's trying to replace the zinc. So you need to look, is tin SN higher than zinc? No. So you just get to put a nice NR for no reaction. You don't have to write any product. You don't have to balance it. Over here, we'll do our next one. Tin is trying to replace hydrogen. I know hydrogen is a not metal, but it's an exception on these. Is tin higher than hydrogen? Yeah, so that's going to be a good reaction. Now, at this point, you need to know what kind of ion this tin is going to form. If it was already combined with the compound, you could figure that out, but obviously it's not. So I have to tell you that. So I'm going to tell you, if you notice on your practice when you get to it, there'll be some transition metals that I've given them a charge. That doesn't mean that this tin right here has a charge, because it doesn't. It's neutral. It's saying when it combines with a nonmetal, then it's going to be a +2. So my formula would be SnCl2, and the hydrogen was kicked off, so now it's by itself and it's diatomic. And then I would need to do a quick balance by putting a 2 in front of the hydrochloric acid. And then that one would be completed. When you do get to balancing these, if it is a good reaction, quite a few will already be balanced, and if not, they should be pretty easy to balance. All right, last one as far as metals go, I have nickel trying to kick off hydrogen. Is nickel higher than hydrogen? Yes. So once again, I have to tell you what nickel this is going to form. It's going to form a +2. So my hydrogen is kicked off, it's diatomic, and I end up having nickel oxide. It kicks off both of the hydrogen if it's combining with water. So that's where my H2 comes from. And then that one is already balanced. Same thing if we're doing our nonmetals. Chlorine is a nonmetal, so it's not trying to kick out the sodium, it's trying to kick out the bromine. So you got to go to the nonmetal, the little short side. Is chlorine stronger than bromine? Yes. So I'm going to get sodium chloride plus my bromine diatomic. And so I've got to put a 2 in front of sodium bromide and a 2 in front of sodium chloride. No, it does not. Here it has a 2 because it's all by itself. It's diatomic. Here it combined with sodium, and sodium's a +1 and chloride's a -1, so they cancel each other out, so it doesn't have to have a subscript. No, the subscripts don't travel. All right, why don't y'all try those last 3, and remember, if the element that's by itself is not strong enough, then you're just going to write NR and you're done with that. I'd probably like a quiz that's the whole list of NRs. All right, what did we get for this one right here when iodine plus potassium bromide? An NR? Yes, all right. Oops. NR. So we'll come back here. Fluorine's trying to replace bromine. Is that possible? Yeah, so what do we end up with? Perfect. Perfect. Plus BR2. And we didn't have to do anything to balance it, right? It was already balanced. And what about the last one here? Another NR. All right. So that's what you're working on practicing today. And then we'll move on to combustions. I think this is a little easier than the last two that we've done. Definitely maybe easier in writing the ionic compounds. So y'all have a little bit of time, about 15 minutes to practice on some of that. And then we'll move on to combustion tomorrow, which aren't too bad either. So we should be testing on this unit plus doing some labs next week.